The next very important data structure in Python are sets. Sets are unordered collection of items, which means just like if you recall, which means they cannot be indexed, right? So the moment something is unordered, it means it cannot be indexed. Which other data structure in Python cannot is unordered? If you look at our hash table or dict, right? Dict is also unordered and hence cannot be indexed, right? Self the set data structure is mutable, which means we can add and remove items from it. Sets are typically used to perform mathematical operators like set union, set intersection, set symmetric difference, and things like that. We'll see. For those of you who know what is a union, intersection, or symmetric difference, that's great. Otherwise, we'll anyway learn these concepts in this discussion itself, right? So let's understand how to create a set to start with, right? So again, sets are typically created using curly braces, just like your dicts. But in a dict, you have key one, value one, key two, value two, etc. Right? This is how you define a dict, a dictionary basically. A set does not have key value pairs, it just has elements, right? If I say print s, I get this, and the type of s is set, right? The most important thing in sets is sets do not allow duplicate elements. For example, if I create a set with 1, 2, 3, 1, 4, so if you look at this, the element 1 is repeated twice. But when I print s, element 1 is printed only once. So set here is the mathematical set, right? If you have a set of numbers 1, 2, 3, 1, 4, internally where whatever is repeated is stored only once. The other entity is removed. So sets do not have duplicates. Every element, every instance is stored only once. Every value here is stored only once and exactly once. Okay. So that's a very, very important property of a set. Now let's see how to make a set from a list. Suppose if I have a list like this is a list. I can call the set constructor here, right? I can just call this function set here, which returns a set from this list. Now when I print s, you'll see 1, 2, 3. You'll not see this one repeated because the property of a set is that there are no repetitions of an item, right? Similarly, you can initialize a set, an empty set like this. You can just call this function and it will create your s type. Now if you print type of s, it will give you set, and this set is empty set. Okay. Now let's see how to add elements to a set. Now how do we do it? It's very, very simple. So before we go into adding an element, let's see how to index, if we can index. Remember, a set is unordered. A set is unordered collection of items, which basically means you cannot index, right? We just discussed this a while ago at the start of this discussion. But let's see, let's try to do it and see the error that we get. Okay, suppose if I create a set S containing two elements 1 and 3, if I say print S of 1, it immediately gives you a type error saying set objects do not support indexing, which means they're unordered, just like your dictionaries. Okay, that's a very, very important property of a set. Now, if you want to add an element to a set, you can add an element because they're mutable. Remember, sets are mutable. Sets are mutable, which means you can add and delete elements, just like in dictionaries. So while if you, just to quickly recap, your tuples are not mutable. Tuples are immutable, right? Your lists, your sets, and your dicts are all mutable. Okay, so that's an important thing. Mutability and orderedness, whether a set is whether a data type is ordered or unordered, they're important things. Okay, so when I add 2 to it, so initially I had just a set of 1 and 3, right? I just had a set which is 1 and 3, right? Now as soon as I give the function add 2, my set becomes 1, 2, and 3. Now I can add multiple elements using this function called update. In this update, what I've given inside this is basically a list, right? I can give a list here. When I give a list here and when I print s, so what are the unique elements? I have 1, 2, 3 here. I have 5, 6, 1. The unique elements are 1, 2, 3, 5, and 6, right? I can use the update function slightly differently. Now my set is 1, 2, 3, 5, 6. I can say s dot update and I can give multiple parameters like this. This is a list, right? And this is a set. What it will literally do is it will try to add 8 and 9. So you have 1, 2, 3, 5, 6. It will add 8 and 9. It'll add 10. 2 and 3 already exist. So your final set is going to be 1, 2, 3, 5, 6, 8, 9, 10. Right? You can use the update function to add a list and also a set. You can just add a set, you can just add a list, you can add lists and sets any way you want. Okay. So if you want to remove an element from a set, how do we do it? It's very simple. So imagine if I have a set 1, 2, 3, 4, 5. I can give it any order, right? The order doesn't matter. Okay. Because set is a collection. It's got nothing to do with ordering. If I say print s, it prints 1, 2, 3, 4, 5. If I say discard 4, discard basically means remove the item 4 from the set. Now what I have, this printf statement now returns 1, 2, 3, 5, right? So discard is the function that you're looking for when you're trying to remove elements from a set. Similarly, there is another function called remove itself. Okay, there is another function called remove itself, which will also remove the element that you want to remove. So now my set S is 1, 2, 3, 5. If I say remove 2, it will remove 2 and I'm left with 1, 3 and 5. Now, if I say remove 7, now my S set is 1, 3 and 5, right? Now if I say remove 7, what will happen? It will generate a key error. Let's see the type of error that will generate. It will basically say it's a key error, which means this key 7 does not exist in your set S, right? But if you say discard, let's see what happens when you say discard. There's a subtle difference between discard and remove. If you say discard, it won't raise an error because 7 doesn't exist in your set, right? Your set itself was 1, 3 and 5. Okay, you tried to discard 7, but 7 doesn't exist, so but it doesn't raise any key error. On the other hand, the remove function here raised a key error when this element did not exist, right? When you print s, you're still left with 1, 3 and 5. There are a couple of other functions that you can use. There's a function called pop. Okay, so let's assume my set is 1, 2, 3, 4, 5. Again, order doesn't matter here. If I say pop, s.pop, it will remove one of the elements at random. It can remove any of these elements at random. In our case, it removed the element 1, right? So if I again, so now my s is 2, 3, 4, 5. If I say s.pop again, it will remove some other element and I'm left with 3, 4 and 5, right? Pop removes one element at random. Okay, so now let's see another function which is called clear. Suppose if I have a set like this, which has 1, 5, 2, 3, 6. If I say s.clear, it removes all the items in the set. Now, if I try to print s, I basically get an empty set, right? So clear is the function you're looking for if you're trying to remove all the elements in a set. Now let's look at some set operations. Like for those of you who do not recall set operations, let me draw a simple diagram. Suppose if I have two sets like this is set A and this is set B, right? A union B are the elements which are there in both A and B, right? So this whole thing is A union B. This whole orange lines are your A and B, right? So while set intersection are this region is your set intersection. The common elements between, so A union B is written typically as this, which is all the elements, which is your orange points, right? A intersection B is your green area, right? So this is a very simple notation for you to understand what are these. There is also something called as, there's something called symmetric difference. Okay, let me anyway explain that. Symmetric difference between A and B is basically let me highlight this. Anyway, we'll discuss that when the time comes. Let's go one by one. Okay, so to actually get set union, you can just use this OR operator. So what this means is, if an element is there in set 1 or in set 2, you make it in your final set. Okay, or you can also say set 1 union set 2. This will give you the union operation between two sets. Similarly, for intersection, we have AND. So AND here basically means if an element is there both in set 1 and set 2, then it will be there in its intersection. Or you can use a direct intersection function itself here and say set 1 dot intersection set 2. Now all these examples will flow very easily for you, right? Now let's just write our sets here. Our set S1, our set 1 is 1, 2, 3, 4 and 5. Our set 2 is 3, 4, 5, 6 and 7, right? the union of them will be 1, 2, 3, 4, 5, 6, 7, right? So the union works. The union also works here, right? Now let's look at intersections. What are the common terms between set 1 and set 2? Your 3, 4, 5 and 3, 4, 5 here. And that's what you have in your intersection. Now the next interesting operation is called set difference. So set difference works as follows. It's a very interesting operator. So set difference basically says that, so if I say set 1 minus set 2, okay, it is basically, let me draw this diagram so that it helps us understand. Suppose if this is set 1, this is set A and set B. Set A minus B is basically this region. Items which are there in set A but not in set B. Okay, so that's what is the set difference. This is nothing but A minus B. This highlighted region is nothing but A minus B. So out of 1, 2, 3, 4, 5, 3, 4, 5 are there in set 2. Only 1 and 2 are not there in set 2. And hence you get your set difference as 1 and 2. And for set difference, you can use either the minus symbol or the difference function. The next interesting thing is called symmetric difference. This is a very interesting operator. So let me explain you. Okay, so our set 1 was 1, 2, 3, 4, 5. Right? Our set 2 is 3, 4, 5, 6, 7. Right? Let me draw the Venn diagram. So these, by the way, these diagrams are called Venn diagrams in set theory. Okay. Suppose if I have two sets A and B. Okay. My symmetric difference of between A and B is basically those elements that are there, that are present only in A and B but not in both of them. Okay, so you can write set difference, you can write symmetric difference mathematically as A union B minus A intersection B. What is A union B? A union B is this whole region. A intersection B is this region. So if I remove this region from the whole region, what I get is the symmetric difference. And symmetric difference can be computed. So what is the symmetric difference between these two? Elements which are present only in set 1 or only in set 2, which is 1, 2, 6 and 7. Because 3, 4, 5 are present both in set 1 and set 2. The operator for symmetric difference is this exponent operator. There is also an explicit function called symmetric difference that you can use. Okay, so these are operators, these are set operators that are extremely used in mathematics. By the way, even in data science we'll use them a lot. Now the other set of interesting operators are called is E subset. Imagine if I have two sets A and B, right? Your CD is your whole set Y here is present in X. So if you have a set like this, if you have a set A like this, if a set B, if the whole set B is part of set A, then we say that B is a subset of A. And B is a subset of A, right? And a simple function to check whether one set is a subset of other set is E subset, right? Of course, your Y is completely, because both elements C and D are there also in X, your Y is a subset of X, but X is not a subset of Y. There are a special case of sets called frozen sets. Okay, so it has some interesting properties. Frozen sets are like, for example, we remember tuples and lists are very similar, except that tuples are immutable, right? Tuples are immutable while lists are mutable. A similar relationship exists between sets and frozen sets. Okay, a frozen set is basically an immutable set, and you can create a frozen set using the function frozen set. And sets cannot be used as keys in a hash table or a dictionary, right? You cannot use a set as a key. Set as a key in a dictionary is not allowed. But a frozen set can be used, because frozen set is like a constant. If you want to think about it, so immutable stuff are like your constants, right? While mutable things are like your standard variables. This is how I remember in C. In C, you have constants and variables, right? Constants are those variables which you cannot change. So constants are immutable. So you cannot have set as a key in a dictionary, but a frozen set can be used as a key in a dictionary. This is because of some internals of how things are hashed, how the mathematics and the underlying implementation of hash tables and dictionaries are. Okay, so we, frankly speaking, have not used frozen sets a lot, but it has some applications in data science, a few applications. I will not use it extensively, to be very frank with you. Okay, so I can create a frozen set1 using the frozen set function, and I can give it a list and it will create these two. Okay, now when I try to add an element, it will give me that frozen set object does not have an attribute add, so you cannot add them. Okay, so frozen sets again do not support indexing just like your regular sets, but they support all the standard operators. You have your union, you have your intersection, you have your symmetric difference. All these operators are supported in on frozen sets just like your regular sets. Okay, so frozen sets are sometimes used, especially when we have to use them as keys for hash table, but they have very limited applications, especially in data science.